So in C programming language, you can visualize or you can think of the entire memory as a one-dimensional array. Even though you are going to have various data structures and you could look at the data structures in a different view, but actually in C programming language it is accessed as if it is a one-dimensional array. So I'll just explain you how it works. See, you can think of this entire memory as one-dimensional array like this, right? And then if there is any object in C, like an integer or character, whatever, any variable that will be assigned. See, let us say they are all bytes, okay? And your system could be either byte addressable or word addressable, right? And now if you declare any variable, that variable will generally be stored in the memory at some location, and in order to make it easy for you to access it, generally we have a name for the variable. For example, if you declare char a, right, then a will be given some storage, which means the name a is nothing but whenever you use this name a, you are actually inside this cell. If this cell is dedicated for the character a, then whenever you call this name a, you are actually standing inside this cell. That is the meaning of it, okay? And now how many cells does a variable take or consume, that depends on the implementation. Sometimes that all depends on the implementation. See, many people think that character size is 1 byte and integer size is 2 bytes, long size is 4 bytes, but it is not fixed like that. And even if you can see that some of the questions are asked in which they might ask you what is the size of a character, they should not really ask you that, because the character size or integer size or long, whatever it is, that all depends on the implementation. Some implementations might use by implementation I mean the platform also. We have 64-bit operating system, 32-bit operating systems. Therefore, depending on the platform on which your program is running, each variable is going to take some size, right? But this size is once decided, it is going to be fixed like that. But then you cannot fix it like character should always be 1 in all the platforms. It doesn't. It is not true. It varies from implementation to implementation, of system to system or platform to platform. Anyway, most of the implementations have character size as 1, but then they should not really ask you such question, what is the size of a character, okay? And then if you have integer, let us assume that in this platform integer is going to take up 2 bytes and each cell is representing 2 bytes. Then whenever you talk about b, then b is actually now having these 2 bytes occupied. Got it? So this is b, this is a, like that. So whenever you want to access it, you can access it using the name. That is a quite popular method. The popular method to access any variable is by using their name. So whenever you are talking about the name of a variable, you are actually inside the cell and you are talking about that, right? And the other way to access it is by using their addresses. So any variable or any entity that has been given some memory inside that has been given some space inside the memory will definitely have a address. Now, in order to access that particular entity, you need not use the name always. Sometimes if you use the address, you can completely avoid the name, one thing. And second thing is, even if you have name, if you use the addresses, it will be faster to access. See, as you know, even though you are trying to access a variable by name, ultimately it has to be converted to logical address, and then logical address has to be converted to physical address. Therefore, anyway you need the address to access a element. So if you are already accessing the element by address, it will be faster. So sometimes it is convenient to use the addresses rather than the names. One thing is for sure, if you use the names, it will be easier for us to read it. If you use the addresses, it will be faster for the machine to implement it. That is where pointers come into picture. Pointers generally handle the addresses, and whenever you write any program or any entity with pointers, it is supposed to run faster compared to the programs which does not have pointers. That is one advantage. And the other advantage is generally the dynamically created data structures, you cannot name them when you create them. Therefore, at that point, only access or only handle to access them is address, right? So anyway, pointers are going to play a key role, especially in C programming language, okay? Now let's talk about a pointer. You know this, these are all trivial. So character, integer, long, everything is trivial. Now let's talk about a pointer. What is a pointer is? Pointer is a variable which is supposed to contain the address of some other variable or some other entity. And let's see this. Let us assume that in this system the address is 16 bits. Physical address or logical address? Generally logical address. Okay, if the logical address space is 16 bits, right, then we use a pointer whose size is 16 bits. Okay, let me keep it simple. Let's not talk about logical addresses, physical addresses. That is really not required for Gate. I don't want to confuse you with that concepts combined with the pointers. Let's make things simple. Okay, so every system is going to have some length or some bits used to address the memory, and therefore your pointer should be able to hold those many number of bits. So the size of a pointer again depends on the platform. In some platforms they have 16-bit addresses. In that case pointer is going to be 16-bit variable. In some platforms there is 32-bit addresses, therefore pointer size is going to be 32 bits. So either, okay, let's see this. How to declare a pointer is like this: int star, let us say p. This is how we declare a pointer. Now when I write like this, it means that star p, when I write like this, p is a pointer because it is written as star, and one other way of reading it is star p is a variable of type integer. Okay, I'll tell you what it is. Let us say, now once you declare this, then what you could write is p equal to %b. Okay, now this %b will get the address of b and it will assign it to p. So if you watch it, if I write p equal to ampersand of b, there are two operators. One is equal to, another is ampersand, and we have already seen that ampersand is having highest precedence, right, unary operator compared to the assignment. So this ampersand operator, it is also called as address operator. It is used to get the address of b, and you can get the addresses of only the variables and the other structures which are declared in the memory. For example, you cannot get the address of expression. Expression cannot be declared in the memory, or you cannot get the address of a constant. Only the things which you can get the address of are variables which are actually allocated some memory space, right? So by writing like this, what happens is you are going to get the address of b and you are going to put that address in p. For example, let us say in this platform the address is 8 bits, then pointer is going to take up only 1 byte, right? And now b is already somewhere, b is occupying 2 bytes, right? So even though b is occupying 2 bytes, you need not allocate 2 bytes to pointer, because pointer has to just hold the address. Let us assume that this entire addresses, all the addresses are just long enough to fit in 1 byte. Then what happens is, let us say the address of this one is 100, this element, and this one is 101. Then what is the starting address? 100. So by writing this line inside p, 100 will be saved. What is the meaning of this? That p is going to point to a element, right, which is of type integer, and the address is 100. Okay, it means like this. This is the meaning of a pointer, and either it is a integer or character or any other structure, pointer size is always going to be same. Why? Pointer is going to contain the address, and whatever the element it is, the size is going to vary, but its address is going to be constant, isn't it? So pointer size is going to be exactly the same number. Okay, so I'll tell you, if you want this any correlation, you can think of it like this. We have houses and each house is of different size, isn't it? But all the houses will have same size address, right? Either it is a small house or a big house, address is always going to be same, isn't it? Therefore a pointer should be able to hold the address, so it is going to be the same for all the data structures. So remember this carefully. Any data structure it is, whatever it is, always the address is going to be same. You need not change the size of the pointer depending on the type of the pointer. Then why should we write this? If I say that everything is going to have the same size, then why should I write this? I could have even written this, right? Char star p, and p can point to integer, isn't it? Yes, that is true, you can do that, but the problem is there. The problem is address arithmetic. I'll talk about it later. Why should we say what type of element that a pointer is pointing to instead of see, depending on whatever the type of the element it is, you are always going to have the same size of the pointer. Then why should you differentiate it? Why should I write int star p, char star p, or anything like that? The reason is, if you don't declare the type of it, later there is a problem called as arithmetic, address arithmetic. I'll talk there why it is required. I'll say about it there. Okay. Now one thing is, p is pointing to this, right? So now if I use the name p is as good as using the address 100, right? Now when you have the address 100, it is as good as you are standing here. Understand this? Whenever you have address at hand, it is as good as standing there at the doorsteps. And if you have to get inside the element and access the element, then we have to use one more operator, which is called as star, right? So this star is also called as dereferencing or indirection operation. See, ampersand is used to get the address, okay, and star is also called as dereferencing or indirection operator. And whenever I apply this star to a pointer, what happens is, if you have the name of a pointer, you are actually standing outside that memory cell, and when I apply a star, you are actually getting inside it, right? So whenever you call it with a name, you are actually inside it. So if I use a name of a variable, I am standing inside. If I use the address of a variable, I am standing outside. And if I use star to the pointer, I am standing inside. So if you have to access a variable inside the variable with a pointer, then you should always use the star. Remember this? So what it really means is, now whenever you do this, wherever you have used b, that can now be substituted with star p in every expression. So b and star p both are same, which means using a name to access a variable or star p to access a variable, when p is pointing to b, both are same. Got it?